Parts from FTC Team 7477, and today we're going to be talking about encoders and how to use them. So encoders are a very useful tool in FTC, and they are on motors, and they record how many ticks your motor has completed, and that is the unit of the motor, the unit of the encoder, ticks. So first I wanted to talk a little bit about how exactly the encoders work. So basically, let's say you have a motor, and it completes one whole revolution, like that. That's a 360-degree revolution. And each motor has a separate ticks per revolution measurement. And you can find that on the website of the motor that you have, the web page. So let's say for this one that we have, it's 500 ticks per revolution. If I make one rotation of the motor, my encoder will read 500 ticks. Now let's say I do a second revolution in the same clockwise direction, it will now read 1000 ticks, right? And if you remember in the motors video, we discussed the stop and reset function, which resets the encoder to 0. So let's say at this point, I use the stop and reset function. What that would do is set my encoder reading to 0. So now I have a encoder that reads 0. Now let's say I wanted to change my motor direction, and instead of clockwise, I make it go counterclockwise one rotation when encoder is currently reading 0. Then the encoder is going to read negative 500. If I do another rotation in that same direction, I read negative 1000. But if I rotate in the clockwise direction, now it's going to go back to 0. So that's the basics of how a motor works. And now we're going to get into the actual code for it. So first we're going to start, of course, encoders are used for motors. So we're just going to initialize a motor, and let's call it arm, and initialize the motor using the hardware map. And one thing, the encoder is actually the wire that goes into the white port at the back of the motor and into the white port next to the motor port on the rev hub. So before you actually use the encoder in your code, make sure that you have the encoder plugged in on your rev hub. So now we can use the ARM motor, but remember that we want to use the set mode function to actually set the mode to run using encoders. Like that. So now it will run using encoders. So, sorry, give me 1 second. Okay, so now we have the motor set to run using encoders. Let's use our wait for start function. Sorry, I think that's part of the code I deleted. Okay, so we're back now. Okay, so set mode run using encoder. So now that we have that, we can go into the actual code and start writing the code. So first thing I'm going to explain is how you can make the motor move to a position using encoders, because that's what an ARM motor does, right? It moves between positions, moves between different positions. So let's say I want to move my arm like whatever amount up. Let's use an imaginary motor and say that our ticks per rotation that we discussed before, our ticks per revolution is, let's just say 500, or let's say 1000. You can find this by going on the website of your company that you bought your motor from and finding that motor, and it will have a ticks per revolution and it will tell you what it is. So let's just use 1000. So now let's say I want to move my arm. I want to do a 90-degree turn of my arm from where it is right now. Let's say the encoder is set at 0, and I want to make a 90-degree turn. So the way I do that is, let's initialize a variable that says degrees, but has a variable in ticks per revolution. So 90 degrees would be equal to 250 ticks if it's 1000 ticks per revolution. So now there is a method that you can use with motors called set target position, and you can set a target position in ticks. So we're going to set our target position to degrees. So that's what the motor is looking to go to now. Now there's a specific mode that tells the motor to go to a target position, and that is the fourth mode of these four set modes. So if I use, it's called run to position. So if I set the mode, I can choose run to position. We didn't discuss this in the last video, in the motor video, but basically what this does is once you have a target position set, then the run to position will tell the motor to run to the position. And one thing that you don't want to do is mix up these two. You always want to make sure you set your target position before you set the motor to run to position mode. However, there's still one more step. This will not move the motor. To move the motor, we still actually need to set power to it. So I can do arm.set power, and I can choose whatever power I want. Now, remember that you shouldn't be using a negative power for when you're running to position, because your encoder ticks will either be positive or negative depending on what direction you want to move. So there's no point in setting a negative power because run to position already recognizes which way you need to move, and you just want to set a positive power. So let's say if I set it to 0.5. So let's recap what this does. The ticks per rotation is 1,000, and the target position is 250 ticks. So this arm will move 90 degrees at a power that is half of its full power, right? So that is the main top point of decoders, is to move to another position. And one thing I wanted to address is that there's a way you can set a target position tolerance, and that's recommended because sometimes if it's not, this will try to be exactly at the target position, and it might jitter a bit when it has reached that target position. So a target position tolerance will basically, instead of one specific value, give it a range. So if my target position tolerance is 5, instead of 250, it'll be a range of 5 below 250 and 5 above 250. So 245 to 255 to make it get to the position easier and not jittering to try to move to the position. So the way we can do that is the set target position tolerance is a DC motor X function. So you want to change our arm to DC motor X. And then after this set target position line, we can add a set target position tolerance line. And let's make it 3. And what this will do is make a range from 247 to 253 that the arm can actually be between, and it'll be fine. So now we have moving to a position, and I want to discuss one more thing, is the fact that let's initialize another motor to show this, and I'm going to call this a sweeper, which is a continuously spinning intake sweeper. And I want to show the other use of an encoder. Now I will set sweeper to the same mode, run using encoder, but for a sweeper all I need to do is set power to it. So all I need to do is sweeper.set power 0.5. And you might be asking, what's the point of having an encoder then? But encoders also regulate your speed. So if I use an encoder, my speed will be constant. It will always be sweeper.set 0.5 will always have the same exact speed. If I don't use an encoder, it'll be highly battery dependent, and it will cause distinct variations in the power of the sweeper depending on the battery level of your robot. A useful function with encoders is the get current position function, which returns the current ticks value with the motor has. So if I did arm.get current position, it will keep updating this, and I can actually initialize a position. I can actually initialize a variable up here, and that's the position. So I can set it to this, and this will update every cycle of the teleop. So I have like the current position and encoder ticks for the arm, and if I wanted to, I could do it for the sweeper too, like this. Get current position. And this is pretty useful because there's many cases where you need to know at what point in this rotation the motor is, maybe to like set different safeties on your motors and stuff like that. So yeah, that's a very useful method showing exactly where the motor is. And unlike servos, which show what the servo is set to go to, the motor actually shows what it's at right now. So that's it for today. Thank you for watching.